Hello everybody and welcome back to the channel. My name is Dave. For my subscribers, I know I've been away for quite a while, but I'm back now, and in this video, we'll be talking about trigonometry as it applies on the SAT-1 math section. Now the SAT includes several questions that are drawn from the areas of geometry, trigonometry, and the arithmetic of complex numbers. Approximately 10% of SAT questions will be drawn from these areas. SAT trigonometry questions are not that difficult, and knowing a few definitions and their relationships between them will give you an edge over the competition. The first topic we'll be looking at is the special right triangles, in particular Pythagorean triples. So what is a Pythagorean triple? Well, a Pythagorean triple simply consists of three positive integers a, b, and c, which satisfy the Pythagorean theorem, a squared plus b squared equals c squared. And on the SAT, the ones that are useful to know are the first three, in particular 3, 4, 5, 5, 12, 13, and 8, 15, and 17. These frequently pop up when used with right triangles on the SAT, and knowing these off the top of your head can often help you to save time and do calculations quickly. Working with Pythagorean triples is that these numbers in fact represent the ratios of the side lengths. So, for example, if we have a right triangle and the legs are known to be 10 and 24, then the third side would be 26, multiplying 13 by 2 to get the length of the hypotenuse. There also exist special right triangles that are defined by their angles. One of these is the 45-45-90 right triangle. In this triangle, each side has a length of x, and the hypotenuse, by the Pythagorean theorem, has a length of x times the square root of 2. Another special right triangle is called the 30-60-90 right triangle because it has angles of 30, 60, and 90. In this case, the angle on the right-hand side is 30 degrees, and the length of the side across from it on the left is x. If this is the case, then the longer leg has a measure of x times square root of 3, and the hypotenuse has a length of 2x. These ratios are in fact provided on the cover sheet of the SAT at the beginning of each math section, so there's no need to memorize them. However, you do need to know how to work with them, and we'll be doing one example later in this video. In addition to knowing about Pythagorean triples and special right triangles, you should also know about the trigonometric ratios. In particular, these are sine, cosine, and tangent. If we have a triangle ABC, with C being the right angle, we refer to the side across from A, in other words BC, as the opposite side. We refer to AB as the hypotenuse, and we refer to AC, the side that is closest to A, as the adjacent side. Using this definition, the sine of A is the opposite side over the hypotenuse, which in this triangle is BC over AB. The cosine of A is the adjacent side over the hypotenuse, which is BC over AB, and the tangent of A is equal to the opposite over the adjacent, which is equal to BC over AC. There are also three more trigonometric ratios that might pop up from time to time. These are the cosecant of A, which is the hypotenuse over the opposite, which is AB over BC, which is simply the reciprocal of sine of A. There is also the secant of A, which is the hypotenuse over the adjacent side, which is AB over BC. And the cotangent of A, which is the adjacent over the opposite side, or AC over BC. Notice that the secant of A is the reciprocal of the cosine, and the cotangent of A is the reciprocal of the tangent. Using these, we can find some very common trigonometric ratios, which you'll see quite frequently on the SAT. If we want to find the sine of 45, this is actually equal to the cosine of 45. And using our definitions, this is equal to the square root of 2 over 2. The tangent of 45 degrees is simply 1 over 1, which is equal to 1. The sine of 30 is x over 2x, or 1/2. The cosine of 30 is x times the square root of 3 over 2x, and the x's of course cancel to give us the square root of 3 over 2. And the tangent of 30, using the definitions on the previous slide, are 1 over the square root of 3, or if the denominator is rationalized, square root of 3 over 3. The sine of 60 is equal to square root of 3 over 2. The cosine of 60 is equal to 1/2, and the tangent of 60 is equal to square root of 3. Some more trigonometric ratios that you should know are that the sine of 0 and the cosine of 90 are both equal to 0, and the sine of 90 and cosine of 0 are both equal to 1. We can sum up these common trigonometric ratios in the table. So as we can see here, it's easier to memorize if you look at the numbers in red under the sine column. In this case, you simply need to count from 0 to 4. The sine of 0 is the square root of the quantity 0 over 4. The sine of 30 is the square root of 1/4. The sine of 45 is the cosine of 2/4. The sine of 60 is the square root of 3/4. And the sine of 90 is the square root of 4/4. For cosine, they simply go in the other direction. That is, they start at 4/4 and go down to 0/4. Now let's move on to doing some practice problems. If cosine of A is equal to 5 over 13, what is the value of 1 plus the cotangent of A? And the choices they give us are 12 over 5, 17 over 12, 13 over 5, or 17 over 13. It's always good to draw some kind of diagram if you have the time. In this case, we can label the shorter side 5 and the hypotenuse 13. Because the cosine is defined as adjacent over hypotenuse, this would mean that the angle alpha is at the top of the triangle. And we can clearly see here that this is a 5, 12, 13 triangle, so that the missing side has a length of 12. Because the cotangent is defined as the adjacent over the opposite, this means that the cotangent is 5 over 12. And based on this, we can add 1 to this. So 1 plus the cotangent of alpha is equal to 1 plus 5 over 12, or 17 over 12, which means that answer choice B is the correct answer. In this question, we have to find the area of the quadrilateral JKLM. We can clearly see that MLJ is a 45, 45, 90 right triangle, so this implies that LJ is equal to LM is equal to 14. We will mark these on the diagram and move on. We can see that the angle measure of JKL is equal to 30, making MLJ a 30, 60, 90 right triangle. Using our knowledge of the ratios in a 30, 60, 90 right triangle, we can say that LK is equal to 7 and that JK is equal to 7 times the square root of 3. To find the total area of the quadrilateral, we have to add up the areas of the two triangles. So the area of MLJ is equal to 14 times 14 over 2, or 98 square units. And the area of JKL is equal to 7 times the square root of 3 over 2, or 49 times the square root of 3 over 2 square units. The total area, once again, is simply the sum of these two areas, which means that D is the correct answer. For our last practice question, we have a word problem. Pedro measured the angle of elevation from the ground to the top of a tree to be 59 degrees. If Pedro stood 12 feet from the base of the tree, and his eye height is 5.5 feet from the ground, how tall is the tree? Here are the answer choices. And once again, it's often helpful to draw some kind of diagram so we can mark it in later. We'll let Pedro's eye level be located at A and his line of sight be AB. Therefore, the measure of angle A is 59 degrees. We would like to find BC, and since we know AC, we would use the tangent function to find the answer. We're going to use a technique here called ballparking. Since 59 degrees is close enough to 60, we will write down that the tangent of 60 degrees is equal to h over 12. At this point, all we have to do is solve for h. So we have that h is equal to 12 times the tangent of 60 degrees, or h is equal to 12 times root 3. Since we know that square root of 3 is in between 1 and 2, we know that the height of the tree from Pedro's eye level must be between 12 and 24 feet. However, we still have to take into consideration the vertical distance from Pedro's eye level to the ground. After subtracting 5.5 from each choice, the only reasonable answer in this is C. Okay, so this is the final answer for this question. I hope you liked this video, and I hope it was helpful in helping you prepare for the SAT. If you did like this video, please give me a thumbs up and subscribe to my channel. Thank you very much, and I'll see you in the next video.